again, and right now we're going to be looking at earthquake depth. Um, Earthquakes can occur. Again, earthquakes occur whenever two parts of the Earth's lithosphere move suddenly in relation to one another. Tension is released and energy is released. The tension overcomes the friction. There are certain inferences that we can make about earthquake depth based on the type of boundary where the earthquake occurs. As we know, there are three types of plate boundaries. There are transform, divergent, and convergent. And I want you now to think about those three types of plate boundaries, and then I want you to open up our ESRT page 5. So if you don't have it, please pause the video and then open up ESRT page 5. And when we go to ESRT page 5, we look at the different types of plate boundaries. And forgive me for the resolution of this map, but it was the best I could do on short notice. So let's think about where divergent plate boundaries are, and let's think what's happening at a divergent boundary. Crust is being pulled apart. Is there any part of that motion that would indicate to you that an earthquake would occur deep in Earth's crust? Or a transform fault where the two plates are moving side to side in relation to one another. Is there any part of that type of boundary where there is diving going on, where the crust is getting deeper into Earth's surface? No. Really, where we're thinking about where there might be a deep earthquake is at what boundary is this now right here, where the two pieces are coming towards each other? That is convergent, where they're coming together. In a convergent subduction boundary, especially, you know that the oceanic crust is diving underneath the continental crust. So here at the Juan de Fuca, my favorite plate, here there's a convergent subduction boundary all around the Pacific, except for down here, there's convergent subduction. Where the Nazca plate is subducting under the South American plate, there's some subduction there. Down here in the Sandwich plate, interacting with the South American plate, there's a whole bunch of places where there's convergent subduction boundaries. So let's go to the still photo right here. Here is a close-up. This is an overhead view on the right of the Pacific plate subducting under the Eurasian plate, excuse me. This is the Japan trench. And we see the color blue near the trench, near the subduction, at the first part of the subduction zone. We see the color yellow further horizontally, more horizontal kilometers from the trench. And we see the color red dominating the furthest horizontal distance from the trench. This is our overhead view. Let's translate that to this cross-sectional view. So I'm going to bust out the pen, and I'll just go with red again. Okay. So this right here, that's the trench, and this right here, that's Japan. You can label that in your notes pack, please. We have this oceanic crust subducting. Whoops, lost it a little there. Oceanic crust subducting, that's the subducting plate. So this thin oceanic crust subducting under the continental crust over here. And when if the earthquake occurs here, where the crust is first subducting at this shallow depth, you're going to get a shallow focus. This blue goes with this blue, okay? And if the tension builds up here and there's tension and friction and builds up here, but then it's suddenly released here, that would be an intermediate depth focus. And when I talk about depth, we should know that this is the what of Earth. Whenever we're drawing the surface of Earth, we always draw our person because that's where we live, right? We live at the surface. This is really hard to do. Okay, we're talking about depth. We're talking about how deep below the surface are we going? Is it a shallow depth, an intermediate depth, or a deep depth? Okay, so depth increases. The value of the depth increases as you go further from the surface of Earth. Okay, if the stress builds up here, and the stress is released here, it overcomes the friction down here, well, that's really far from the surface of Earth. So we call that a deep focus. So this cross-sectional view correlates to this overhead view. So as the horizontal distance from the trench increases, that's what I just drew was this. Okay, the depth of the earthquake also increases. So that is a direct relationship, all right? So let's go on to the next slide here. Oopsie, Go on to the next slide. Here's another view. We do have a vertical exaggeration of 5 times here. So here we have the Pacific plate interacting with the Australian plate. And here again is the Pacific plate subducting beneath the Australian plate. And here are your deep focus earthquakes, horizontally very far from the actual boundary. Your intermediate quakes, less horizontal distance from the boundary, and your shallow quakes very close to the plate boundary here. All right. Okay. So what we're going to do now is we're going to go to an animation. I think. How come it's not working? Okay. Let's go. Okay, here we go. Okay. So here are the plate boundaries of Earth, and this correlates to page 5 of your ESRT. So where would a shallow focus be? Where would the focus of the earthquake be very close to Earth's surface? What kind of boundary do you think? Is it divergent, transform, or intermediate? Well, let's find out. Whoa. Looks like you can get a shallow focus at what types of plate boundaries? That's right, all of them. You can get a shallow focus at any one of the 3 types of plate boundaries. What about intermediate foci? What about an intermediate focus? Where do you think an intermediate focus could occur? Divergent, convergent, or transform? Let's find out. So where are all those green dots? Most of those green dots are what kind of boundary? Subduction, right? Convergent boundary, convergent subduction. There's a couple at transform, right? A couple, okay. And deep focus. Where are you going to get only type of boundary? We're going to get the deep focus earthquakes. Yep, say it with me. Convergent subduction. There's your deep foci, right? So over here, Japan, right? Over here. There we go. Look at that. That's the Nazca plate subducting under the South American plate. There's some deep focus earthquakes there. All right. So that is my little tutorial about earthquake depth. Take care, everyone.